Hello Flame community, this is Jeff Kyle with the Flame Learning Channel. In the previous video, we introduced AutoMatte ML and went over some of the changes to the selective workflow. In this video, we'll be explaining the selective matte pipeline in a bit more detail and demonstrating just how you might use AutoMatte and the ML region of interest on your next project. At the very core of the selective workflow is the ability to select or isolate objects. That isolation can be broken into three categories: shape, color, and spatial. When we use these isolations together, they're combined in a specific order, and understanding how that order works will help make sense of the matte pipeline. Keying happens first, and that key is combined via a multiplication blend mode with any 3D AOVs, which constrains the result of the keyer with the AOV. The shape isolation pathway starts with the input matte first, which is combined with any machine learning mattes, and these resulting mattes are further combined with any G-masks. At each step of the way, we have blend mode controls for how these isolations combine with each other, and we have post-processing options like blur or invert to further control the resulting matte. The result of these shape isolations are combined with the resulting color and spatial isolations with one more set of controls to blend, add, or multiply the resulting isolations to finally give us the matte used for a given selective. Let's take a look at what all this means with some examples. Here I am in the effects environment in the image node with this shot here of someone walking through the desert. Let's say I'd like to adjust the color of the ground without affecting the subject. I'll start with a key of the ground, and when I control drag this box here to sample a region, and I press F9 to view the selective matte, the ground looks pretty good, but it's clearly contaminated by the similar colors from our subject's clothes. I'll head over to the ML section and select Add AutoMatte to try to create a holdout for our key. But if you're familiar with selectives, you'll know that what we see here is exactly what we would expect from a shape isolation, which is not giving us what we want. It may be tempting to try to work through some of the blend options here in the ML layer list, but based on what we just mentioned about the selective matte pipeline, these blend options are only for other shape isolations, and the key is a color isolation. What we want is here in the Controls tab, this comp dropdown, which is the shape isolation comp, and it gives us some control over our mattes that we have not had before. If we think back to the diagram we just looked at, this is the option that controls how the shape isolation, in this case the ML AutoMatte, is being combined with the color and spatial isolations, in this case the key. If I set it to add, the two are added together like this, but when I set it to multiply, we get exactly what we need. With a little post-processing shrinking from this tab here, we have our matte all set up and we're ready to make our adjustment to the ground with a surprisingly simple setup. If I want to combine different mattes in the same shape isolation category, it's a slightly different pathway, but a very similar concept. I'll switch over to selective number 2, create another AutoMatte, and this time, let's say I'd like to do a correction just to the upper half of our subject. I'll create a G-mask rectangle with space Command or Control G and drag that G-mask out to where I want it. If we take a look at the selective matte, we can see that the default behavior of this G-mask is to be added to the ML AutoMatte. Once again, because we know the order of operations, and we know that since the G-mask shape isolation part of the pipeline takes place after the ML AutoMatte, we know that the blend operations here on the ML layer list won't give us what we want, and in this case, the answer lies with the blend operations on the G-mask. Over here on the right, if I set this to multiply, and then add a little bit of softness to this G-mask with Shift-A and drag, we get exactly what we need to darken just the upper half of our subject, once again in very little time. I'm here in batch now, and I have another shot here of a field and some interesting objects scattered around. So far, we've seen the AutoMatte do a pretty good job of selecting the full body of a person, which is pretty impressive, but AutoMatte gets its name from the fact that it creates mattes indiscriminately, whether it's a person or a car or a table with a television. We'll just focus on mattes for this example, so I'll call up a G-mask tracer, add a surface to the schematic, and add a matte selective so we can get to work. Adding an AutoMatte to this shot gives us an okay matte of a lot of objects, but because it's analyzing the full scene, the quality suffers quite a bit. That's where the region of interest is extremely useful for not only discerning what we want to isolate, but also for significantly increasing the quality of the mat. Whether we want the sofa, or the rug, or the table is just a slight adjustment away, and the quality is quite impressive. Depending on the objects we're working with, we are not able to be completely granular with our isolations, but we can get creative with the region of interest to our advantage in some cases. For example, if I want to isolate just the table, I can first create an AutoMatte with region of interest turned on and constrain it to the television. Then I can add a second AutoMatte, also turn on region of interest, and constrain it to both the television and the table. And when I set this upper AutoMatte to inside, it uses the other AutoMatte to isolate just the television, and if I wanted the opposite, I can set it to outside to get the table. And of course, if the shot is moving, we'll need to ensure that the region of interest follows the object appropriately, which is where tracking can come in handy. Just as it can be useful to not look at the result of a selective while tracking, here when we're generating a mat, it can also be useful to not look at the result of the mat when we're dealing with machine learning calculations to avoid two calculations at once. So in my case, I'll look at the F1 or front view while tracking to make sure we aren't calculating each frame of the machine learning mat while we're tracking. That's all tracked, and now our mat is looking good. While the AutoMatte is very good at specific, discernible objects, it's not made to handle large spanning things like a sky. But that's where, in this case, we do happen to have a machine learning sky model that's made just for that. And while its training is not quite as up to date as AutoMatte, with the introduction of the region of interest tool, there are now new ways to bring new life into models like the sky here. I'm going to use action for this example, hooking up the back to this sky plate here, adding a new media to the action, and then hooking that up to our shot. If I head to the action schematic, I can pull up the contextual menu for the media that was added in automatically and add a matte selective. Now we're ready to get to work. I'll switch over to the ML tab, open up this dropdown, select Sky, and switch to the Action Selective View F9 to assess the result. We've generated a matte for the sky, but it's pretty clear that the quality is not quite as good as what we were getting from AutoMatte. Part of the reason for this is that AutoMatte is focusing in on small objects, whereas the sky model needs to span quite a large resolution. I'll keep this selective active and duplicate it just so we can compare it later, but this time turn on region of interest. Now, when I focus in on a small region of the sky, we can see that the quality gets noticeably better. It's a bit of a balance between having enough of the sky so the model can see what to isolate, but not so much of the sky that we take a big resolution hit. It's as simple as adding more sky models, turning on region of interest, and tiling out each one to ensure that the whole sky is covered. It's in this use case that we have this blending fall-off control to help reduce the hard edges when blending multiple region of interest boxes. Once I'm done, we can take a look at the other selective to see the difference between the one-click sky model and the tiled region of interest combination of several sky models. Quite clear that we're getting a lot more resolution out of the tiled version, giving us a much more usable mat. To finish this up, I'll hide the selective with the not-so-good mat and then invert the resulting mat, since that's what will give us our correct composite, and take a look at the result. The beauty of models like Sky here, and of course the new AutoMatte, are that the more training that goes into them, the better they get. This is the first iteration of AutoMatte. As the team further refines the model with targeted training, edge cases, and user feedback, it's bound to get even sharper, more temporally consistent, and speed up our workflows even more. If you like these videos and you're finding them helpful, please subscribe to the Flame Learning channel and click the bell to stay notified about new content. Feel free to comment any questions or suggestions below. Until next time, thanks a bunch for watching.